Okay, let's see how you made out. We have this equation here. First step, isolate the radical. So I add 2x to each side to get here. Then I square each side. So the radical sign disappears. Quantity 2x squared gives me 4x squared. Now I clear everything to one side, leaving 0 on the other side. So I arrive there, and I notice, oh, this is the difference of perfect squares. It's x squared minus 2 squared, so it's really easy to factor it. It factors like that. So it leaves me with two possible roots to the equation. X equals positive 2, x equals minus 2. I have to do my check because they may be extraneous, I don't know. I plug x equals 2 back into the original equation. Remember, every time you ever do a check in any equation, you always go back to the original equation. I plug 2 in there in place of x. Go down here and I get 4 minus 4, which equals 0. So this one works. I have an actual root there. Here's the other possible root. X equals negative 2. I plug that into the original equation. I get here. I get square root of 12 plus 4 gives me square root of 16 plus 4 gives me 4 plus 4, which is 8, which is not 0. So no, I reject this root. That was an extraneous root. So my answer is x equals 2. Okay, now let's see a variation on this problem. Like I told you, we were going to see a lot of variations in this section. Okay, we saw how to do that. There was one radical sign in the equation, we solved it. But sometimes life isn't that simple. Look at example 2. There are 2 radicals in the equation. There's our problem. The approach is this. Isolate one of the radicals. That is, rearrange your equation so that at least on one side the radical is isolated. Well, luckily for us in this case, they've given us a situation where one of the radical expressions is already isolated. So that's taken care of for us. The next thing to do is square each side. That will get rid of that radical sign. That will make a big mess over here, but there will only be one radical expression left when this is all said and done over here. And on this side, there will be none. So I square each side to save a little space on the blackboard since this is a long example. I'll go right to what that is. I'll do the easy side first, right? Radical sign disappears, I like that. Over here on this side, what's going to happen? This is going to multiply with itself. So I'm going to get 4x minus 8. Then the minus 1 is going to hit the minus 1 because it's going to give me a plus 1 over here. And then, using like the FOIL method in my head, the square root of the quantity 4x minus 8 is going to hit that. And then that's going to hit it again. I'm going to get minus 2 times the square root of 4x minus 8. All right, I'll check my work. Looks good. Any questions? I don't hear anything. Okay, so I have 4x minus 8 plus 1, if I move this over here, minus 2 times the square root of 4x minus 8 equals 2x minus 5. And now I'm back to the problem that we just did in example 1. I've got an equation with just one radical expression, so I apply the steps from there. Isolate this radical. Subtracting 4x from each side, I get minus 2x. Here I have minus 8 plus 1, which is minus 7. I add 7 to each side, so I'll get plus 2. Check my calculations to make sure I'm not going astray. And now, something that's not done in the text is there's 2's all over the place. Deuces are wild, as they say, the card players. Let's divide each side by negative 2 and just clean it up. They don't do it in the book, and it's going to work out either way. But it's always easier if you can make your numbers simpler and cleaner. We arrive at that point. And of course, you know what to do. Just like we did in example 1. Square each side. Okay. And this gives us x squared minus 2x plus 1 equals 4x minus 8. Let's see if we can go up here, squeeze some more work in on this blackboard, whiteboard. I clear everything to one side. And I get there. And you can use your method here to factor this quadratic expression, but you might notice like, oh, this is the square of a binomial, right? That minus 6 and that 9, everything works out happily. It's x minus 3 quantity squared. And this yields one potential root. X equals 3. So we have to do our check. For the check, I go back to the original equation. And we'll see if this works out. I replace x with 3. Over here I get square root of 12 minus 8, which is 4. Over here I get square root of 6 minus 5, which is 1. So it looks like that. So I get 2 minus 1, 1, 1, 1. So it checks. So in fact, the equation does have a solution, and the solution is x equals 1. Keep in mind, it's entirely possible that you can have an equation that has no solutions. That does happen. Another variation on this problem. Example 3. All example 3 is showing you is that instead of radical signs you can use fractional exponents. But mathematically it's the same problem, whether you write a radical sign or express it as a fractional exponent instead. So in example 3, we have the quantity x minus 3 raised to the power 2/3 minus 4 equals 0. Step number 1, probably it's a lot easier to look at this problem and convert it to a radical expression. x minus 3 to the power 2/3 is the same as x minus 3 squared raised to the power 1/3. Let me show you what I mean. Right? We know from our rules with exponents that exponents multiply. So this 2/3 that's there, it can be thought of as 2 times 1/3. And of course it can be thought of as 1/3 times 2 if you prefer. In this case I think it's going to be easier for us to just say, alright, this is x minus 3 quantity squared to the 1/3 power, which is the same as just taking the cube root of quantity x minus 3 squared. Alright, now we're ready for our next step, which is to isolate the radical. Okay? And if you're an experienced and lazy algebraist, you can save all that writing. You say, well, I add 4 to each side, now it looks like that. Now I cube each side. Of course, the purpose of cubing this left side is to get rid of that radical sign entirely. So the only thing that's left is what was under the radical sign up here. And of course, I have to cube the other side, because in an equation, whatever you do to one side, you have to do to the other. So now I have x minus 3 quantity squared equals 64, because 4 times 4 times 4 is 64. And lucky for me, I don't have to go through my steps of solving a quadratic equation. I could just say, ooh, perfect square, 64. I'll take the square root of each side. And I see that x minus 3 equals plus or minus 8. So that means x, if I add 3 to each side of this equation, I get x equals 3 plus or minus 8, which is just a shorthand way of writing a list of two numbers. This is just the same as saying x equals 3 plus 8, which is 11, and also x could equal 3 minus 8, which is negative 5. So there are my two potential roots. Of course, I'll have to check. I'll have to plug x equals 11 back into the original equation. I'll replace x with 11. Does that truly equal 0? I don't know. We'll see if it's an extraneous root or an actual root. Well, 11 minus 3 is 8. And I have to do this. Well, I can say, all right, well, 8 is a perfect cube, so I could take 8 to the 2/3 power and think of it as 8 to the 1/3 squared. And 1/3, of course, means just takes the cube root of it. Cube root of 8 is 2. So we get to that step, which is 4 minus 4, which is 0. So that one checks out. And in fact, if you plug in x equals negative 5, that's also going to check out. All right, now you do it. On the same page, page 298, go ahead and do number 10.